Okay, so some of you have been asking about some more help with balancing chemical equations. So what we're going to do here today is we are going to go ahead and do some more hints and balancing chemical equation practices video. Okay, so a couple of things that we have to remember is that balancing chemical equations, you need to have the same number of atoms on both sides of atoms of each element on both sides of the equation. And this is something that we haven't talked about yet, but it's basically a mole ratio, which is the big numbers, the coefficients, are some type of a ratio that we're going to talk about in the future. And the other thing is we use coefficients, so those are your big numbers in front of substances. Like the example I gave in class is if I took 3x plus x, I got 4x, right? Or not y, but x, right? And so like this 3 and this 4 and then the 1 that would be here, those are examples of coefficients. And remember, like just like in math class, the coefficients multiply by what is behind it. So it's 3 times x, or it's 1 times x, or it's 4 times x. Okay, so that's how we balance chemical equations. Um, so here we go. What this really tells us is that this 2 right here in front of the H2O will distribute itself to the H and the O. So we will multiply the O and we will multiply the H. So I end up with 2 times 2 H's. So there's 4 H's. And 2 times, there's nothing behind the O, so we're going to say there's 1 there. So 2 times 1 will give me 2 O's. So really, that's what this is telling me. If I have 2 in front of water, like H2O, I really have 4 H's and 2 O's that I'm trying to account for. So there's some steps to balancing chemical equations. We're not going to worry about the word equation very much. This is something I tried last year, and I don't need it. We're going to do that later. Translate the word equation to a formula equation. This is how you're going to get them. They will already be in formula equations. We'll list the elements under the reactant arrow and count how many are on each side. We'll do that bookkeeping together. We'll begin by adding coefficients in front of substances to make the atoms equal. And if there's no coefficient, it means that the coefficient is a value of 1, and then we recount and reassess. So that's kind of how, those are the steps that I go through when I balance chemical equations. So let's do a few examples. So here I have H2O breaking apart into H2 and O2. So I'm going to start by identifying the number of atoms that I have. So I have H on the left side and I have O on the left side. So then I'm going to start counting. There's a 2 behind the H, so I'm going to put a 2 here. There's nothing behind the O, so I'm going to put a 1 here. There's a 2 behind the H, so I'm going to put a 2 here. There's nothing behind the O, or there's a 2 behind the O, so I'm going to put a 2 here. Okay. Now, right now, my H's are balanced. And what I mean by that is I have 2 H's on the left and 2 H's on the right. So I really kind of could leave those alone. What's not balanced are my O's. So I have 1 O on the left and 2 O's on the right. So the only thing I can do is add a coefficient of 2 here, which will distribute to the H and distribute to the O, and it's going to multiply. So 2 times 2 H's is 4 H's. 2 times 1 O is 2 O's. So now at this point, my O's are balanced, but my H's are not. So I'm going to go back and try to make my H's balanced by adding a coefficient of 2 here, which will multiply by the H. So 2 times 2 is 4. So this was kind of a simple one. You can leave the blanks blank if you want to. If you don't, like if it's supposed to be a 1, oftentimes I'll just put a 1 in my answer key because it looks a little bit better. So that's our first example. So now I have some hints, okay? The first thing is I usually tell students to balance from left to right. So I always try to balance the first element that's present, and then I just kind of continue working to the right. And I know that at some point or another I'm going to have to go back and reassess, but we're going to do the exact same thing. So as above. So I have K, I have Cl, I have F, E, and I have O, okay? So on the left side, there's nothing behind the K, so there's 1. There's nothing behind the Cl, so I have 1. There's a 2 behind the Fe, so I have 2. And there's a 3 behind the O, so I have 3. On the right side, there's nothing behind the Fe, so I have 1. There's a 3 behind the Cl, so I have 3. There's 2 behind the K, so there's 2. And then there's nothing behind the O, so there's 1. So when I balance from left to right, I'm going to start with K, and I'm going to work my way to the right. So at this point, I have nothing. I have 1 K here and 2 Ks on the right side. So I'm going to put a coefficient of 2 here. That's what I'm going to start with. I'm going to put this, it's going to distribute itself. So now I have 2 times K, which is 1. So 2 times 1 is 2. 2 times Cl, 1. So that's 2. All right. So at this point, my Ks are balanced. My Cls are not. And I want to try to balance them, but they're a little bit wonky. And there's an odd number of chlorines on one side and an even number of chlorines on the other side. So even though we're going to go left to right, I'm going to skip to the iron right away because I think that might solve my problem. So I'm going to go and I'm going to balance my irons, which in this case, there's 2 irons over here and 1 iron over here. So I'm going to put a coefficient of 2 here. This distributes, okay? And so I have 2 irons now, because 2 times 1, and 6 chlorines now. Oops. 2 times 3 is 6. So now my chlorines I have an even number of chlorines over here. So I'm going to go back and try to get an even number of chlorines over here. So what I'm going to do there is I'm going to add a coefficient of 6 here. Now that will multiply by the K and it will multiply by the Cl. So now I have 6 Ks and I have 6 Cls. Now my Cls are balanced, my Ks are not. So to balance my Ks, I'm going to go back and try to put a coefficient of 3 here because I want to have 6 on both sides. So 3 times 2 is 6. So now I have 6 Ks and 3 times 1 is 3 oxygens. So now I have 6 potassiums on both sides. I have 6 oxygens on both sides. And I have 2 irons on both sides, the Fe, and I have 3 oxygens on both sides, the O. So I could go back and put a 1 here, and that might make some people feel better. So that one's balanced. The next hint is something that we call the common ion hint. So when I say something is a polyatomic ion, a lot of times it'll show up in parentheses. So here is something that's in parentheses. And what I'm going to do to try to make our lives a little bit easier, so I'm going to put parentheses around this one. So if you have this something in parentheses and you have the same, so I have SO4 here and I have SO4 on the product side, if they're the same polyatomic ion and they're on both sides of the equation, we can treat them as one unit. So instead of saying I have 1 S and 4 O's, I can say I have 1 SO4. So I'm going to identify what I have. So I have aluminum, I have bromine, I have potassium, and I have units of SO4. So here I have on the left side nothing behind aluminum, so I have 1 aluminum, 3 behind bromine, so I have 3 bromines, 2 behind K, so I have 2 potassiums, nothing behind the SO4, so I have 1 of them. On the product side, I have a 2 behind the Al, so I have 2 of them. I have 3 behind the SO4, which means I have units of SO4. I have nothing behind the K and nothing behind the Br, so I have 1 and 1. Now, in order to balance, I'm going to look at these from left to right again. So my aluminums are not balanced because I have 1 on the left and 2 on the right. So I'm going to start with a coefficient of 2. Coefficient of 2 goes to Al and to Br. So that gives me 2 times 1 aluminum is 2, and 2 times 3 Brs is 6. Okay, so I have my aluminum's balanced, my Brs are not, so I'm going to keep balancing. So I have 6 bromines on the left side, so I'm going to put a 6 here to give me 6 bromines, but also 6 potassiums. Now, looking at this, my aluminums are balanced, 2 and 2. Bromines are balanced, 6 and 6. Potassiums are not balanced, 2 and 6. So I'm going to put a coefficient of 3 here, distribute to the K and also to the SO4. 3 times 2 is 6, and 3 times nothing is 3. So this one happens to be balanced like that. And again, that works when you see something in parentheses on both sides of the arrow. And if it has to be the same thing in parentheses on both sides of the arrow for this one to work. I call that the common ion hint. Odd even hint. This one, we talked about the lowest common multiple, but anytime that you have an odd number or an even number of atoms like oxygen here, which is 2, and an odd number of oxygen here, which is 3, we can use the lowest common multiple. And we can do that the long way, but I'm going to also throw in a different hint today to make it a little bit easier. So I have aluminum, oxygen on both sides of the arrow. On the left side, there's nothing behind the aluminum, so there's a 1. There's a 2 behind the oxygen, so there's a 2. Right side, there's a 2 behind the aluminum, so there's a 1. There's a 3 behind the oxygen, so there's a 3. If I try to balance this going from left to right, I'm going to simply start by putting a coefficient of 2 here, which will give me 2 times the 1 Al. So I've got 2 aluminums on both sides. They're balanced. We're going to leave that alone for now. Now I have an even number of oxygens and an odd number of oxygens. So the odd even hint, excuse me, the odd even hint says that I'm going to take this value right here, which is 3, and place it as a coefficient here. And this value right here, which is a 2, and place it as a coefficient here. So what that does is it distributes to the quantity in question. So 3 times 2 oxygens, is 6. 2 times 2 aluminums is 4. 2 times 3 oxygens is 6. So all I did is I took the subscript down here and I made it the coefficient on the left side, and I took the subscript down here and made it the coefficient on the right side. And then lastly, I have to go back and check to see if my aluminums are balanced. They're not, so I'm going to put a coefficient of 4 here, which now balances them, and everybody's happy. The single element hint, we usually simply says anytime there's an element by itself, try to balance it last. So in this case here, I have potassium, and I have magnesium, and I have bromine. I have 1 potassium, 1 magnesium, and 2 bromines. And on the product side, I have 1 potassium, 1 bromine, and 1 magnesium. Potassiums are balanced, the K and the K. Magnesiums are balanced, Mg and Mg. Bromines are not. So I'm going to put a coefficient of 2 over here. That 2 is going to distribute itself to the potassium and the bromine. So I'm going to have 2 potassiums, and I'm going to have 2 bromines. Now, in this case here, the only thing that's left to balance is this potassium, right? Is this potassium, which I can just simply put a coefficient in front of it, which in this case is going to be a 2 because there's nothing to multiply by. So that makes it a little easier to balance. Always try to do the single ones last. And, the H2 and the O2 hint. So with some of these trickier ones where you see oxygen as one of the last elements, we tend to balance the carbon and the oxygens if they're in the same equation last. So this one here, we're going to start with the carbon. So we have carbon on both sides, hydrogen on both sides, and oxygen on both sides. And when I go to balance those, on the left side I have 8 carbons and I have 1 carbon on the right. I have 18 hydrogens and I have 2 oxygens. And on the right hand side I've got the 1 carbon, but this oxygen shows up 2 times, so it's 2 times and 1. So when I add that together, it's 3. And then the number of hydrogens over here is 2. So up there for a moment. So yeah, 2. All right. So again, we're going to start left to right. So I'm going to balance my carbons first. Put a coefficient of 8 there. 8 times nothing or 1 is 8. So I'm going to put a coefficient of 8 there. 8 times 2 becomes 16 plus this 1 that's over here. So that becomes 17 oxygens. So now we're going to balance our hydrogens. Okay. 18 hydrogens over here, 2 hydrogens over here. Use the coefficient of 9 because 9 times 2 is 18. So that's going to give me my 18 hydrogens. It's going to also give me 2 oxygens. So 16 plus 2 is 7, 16, 17. Oh, no, I lied. Not 2. Silly. I'm going to have 9 oxygens. Okay. So now 16 plus 9 is 25. And so here's where I'm at. So everything is balanced except for my oxygens, and I have this one last oxygen to balance, and it has a 2 behind it. So really it means that whatever the number I'm going to try to balance should be divisible by 2. So I'm going to take my 25 and I'm going to divide it by 2, and I'm going to get 12.5, which means that if I put 12.5 here, I get 25. So this is technically balanced with 1, 12 and a half, 8, and 9. The issue is that you cannot have half of an element. So we're going to double all of the coefficients. So this becomes a 2, this becomes a 25, this becomes a 16, and this becomes an 18. So that only works when we're dealing with, or it doesn't only, but it works a lot when we're dealing with combustion reactions, and so that's our new hint there. And then lastly, we have the water hint. If you see OH in parentheses on one side and water on the other side, I'm telling you to cross out water and rewrite it as HOH. You can absolutely balance it as water, H2O, but it becomes a little bit easier when we treat it as HOH. And I'm going to show you why. So I've got PB, I've got OH, which I'm going to treat now as my common ion hint, and I have H and I have Cl. So if I start with my left side, I've got 1 PB, 2 OHs, 1 H, and 1 Cl. And then when I look at my product side, I have 1 H, 1 OH, 2 CLs, and 1 PB. So when I go to start balancing this, my PBs are balanced because I have 1 and 1. My OHs are not. I have 2 and 1. So I'm going to put a coefficient of 2 here, and that's going to multiply. So 2 times 1 H is 2 H's. 2 times 1 unit of OH is 2 OHs. All right, so the leads are balanced, 1 and 1. The hydroxides, OHs, are balanced, 2 and 2. The hydrogens are balanced, or not balanced, 1 and 2. So I'm going to try to make my hydrogens balanced by putting a coefficient of 2 here, which will distribute to the H and the Cl. So that gives me my 2 H's and my 2 Cl's, and it looks like this is balanced. So those are some hints in terms of balancing chemical equations. And if you need any more help, please feel free to let me know. Otherwise, good luck with your homework, and we'll touch base about it in next class.